Hello everyone, welcome to the lab 4 of ECE573 Advanced Embedded Logic Design. In the previous two videos, we discussed about the two SDS pragmas. One is the SDS resource and the second is the SDS data copy or the data zero copy. Now we'll discuss our last pragma, which is the SDS data access pattern. Okay, we have briefly discussed this multiple time in our previous lab, but here we'll discuss the formally the meaning of the access pattern and the how to enable or disable it. So this SDS data access pattern specifies the data access pattern in the hardware function. For example, when we did the vector multiplication, we are receiving the A of 0, then we are receiving the A of 1, then A of 2 and so on. So that means the access pattern is a sequential. Once we access the A of 0, we are not going to access it again. So this is called as a sequential pattern. But when we did the matrix multiplication, the access pattern was not sequential. So when we access the row 1, we were accessing the column 0, column 2, column 3 of the vector matrix P. And when we are doing the row 2 of the matrix A, we are again accessing the column 0, column 1, column 2. That means we are accessing the data, same data multiple times, and this is called as a random access pattern. Okay. So SDSoC compiler checks the value of these pragmas to determine the what kind of hardware interface to synthesize. When the interface is sequential, then when the access can come up with a very simple interface called as a FIFO interface. But when the access is random, you need to have the memory mapped, memory based interface. Okay, so if the access pattern is sequential, a streaming interface such as FIFO can be generated. Okay, you just need to send the request for the read, you get the next data. You just need to send the request for the write, you don't need to send the address, your data will be written at the next address. But if the access pattern is random, you need to have the RAM interface, that is the memory interface, because you need to send the, along with your read request, you need to send the address from which you want to perform the read operation. Okay, so the syntax is pragma SDS data access pattern. You need to give the array name, which array you are talking about, and the corresponding pattern, whether it's a sequential pattern or the random pattern. And by default, it's a random pattern. So here you can see that I'm using the function foo, where the inputs are A and B. So it's a two vectors of size 1024. Now, if I don't use the pragma, it will be a RAM interface, which we have seen till now in our lab. But if you know that you are going to access the A sequentially, so you can tell the tool that I'm not going to access the A in the random fashion, I'm going to access it sequentially. So I can use this pragma to tell the tool that you can have the simple interface for the A and the RAM interface for the B. Another example, here you can see that I have the function foo, where my first is a pointer A and the second is a vector B of size 1024. Now this pointer A can be a scalar pointer or can be a pointer to the vector. Okay, so first I determine the using the pragmas, I'm telling the tool that my A access is sequential. But for the scalar, sequential doesn't make any sense, right? For the vector, sequential makes a sense, but for scalar it's just one value, random and sequential is same. So when you use such as integer star A in the function definition, you make sure that you tell the tool that the A is a vector and not the scalar, and that's why you use the copy pragmas A into 1024. Okay, so if you don't use the copy pragmas, tool doesn't know whether the A is a scalar or A is a vector, and by default it will treat it as a scalar. Other way of avoiding this problem is that you change the definition of int A star A to int A bracket 1024, which we are doing. I think some of you have asked me this question in the first lab, where when I was calling the software function, I was using the pointer. When I was calling the hardware function, I was using the proper definition of A bracket N. So this is the one of the reason. So if the argument A is intended to be a stream import, two pragmas must be applied. Without this, SDSoC tool synthesize the argument A as a scalar register. Another one is that I have the function A where both the inputs are the vector of size 1024. Then I'm using the data 0 copy on A. So when I use the data 0 copy on A means there will be a memory map port on the IP indicating that the IP has to copy the data from the corresponding location via using the memory map tool. So once the IP has to copy this one, why we need to know about the access pattern? Because whether it's a sequential or not, the memory map remains the same. Memory map protocol doesn't depend upon whether I'm accessing the data sequentially or the parallelly. Memory map is always I give the address, I give the bus length, I give the bus size, and I get the data. So in that case, the second pragmas will be ignored by the tool. Okay, so access pattern pragma is ignored because after the 0 copy pragma is applied, AXI master memory mapped interface will be synthesized for that argument. So you don't need to worry whether it's a sequential access or the random access. Okay, so this is the discussion on the access pattern, and it is important that you understand how you are accessing the data, and based upon that you tell the tool that this is sequential or whether you are accessing the data randomly. It is always good to be explicit and tell the SDSoC tool so that the complexity can be reduced. For example, some of the random interface can be modified to get the streaming interface so that you can get the save some resources.